Hi everyone, this is Ipuvi Mishra, Associate Engineering Manager from MIQ Digital. Today I have my colleague Ambarish Singh, Software Engineer 2, with me. Me and Ambarish will be walking you all through MIQ's journey of migrating from fragmented observability ecosystem to a centralized observability ecosystem. We will be talking about the challenges which we faced with the self-hosted systems and then how we migrated to the centralized one. We will be discussing the impact of migration. We will be talking about the vendor comparison we did as we migrated to a managed centralized observability system. With that, let's dive in. This is me and Amrish Singh, your presenters for today. Who are we? We are MIQ. MIQ is the leading pragmatic media partner. We work with agencies and marketers to ensure that they get the best pragmatic media buy-in. How this is done? This is done using connected insights and data-driven approach, which is powered by close to 150 plus microservices, which are deployed on 20 plus Kubernetes nodes. These services use 40 different tools and technologies. Thus, we need a strong observability system. What this system was and what were the challenges with the system. So we had three different tools for metrics, logs, and traces. At the same time, for alerting, we used to have separate tool, and all these fragmented system used to slow down our debugging process. So how we solved it? We'll be covering four key highlights in the slide. One would be managed platform, which helped us solve this particular problem. That managed platform has provided us with unified observability. We were also able to have advanced alerting in the same platform, and this platform helped us with certain cost efficiency. We had transparent pricing and there were no extra hidden cost involved, and at the same time we were able to save some dollars. So what was the actual impact look like? In summary, we were able to optimize our monitoring coverage by approx 15%. Our developers are happier. Reason being, we had a centralized system to debug now, and we were able to save close to 10K per annum, and this helped us make our debugging 30% more fast. Okay, with that, let's look at the challenges which were there with the current system. The first challenge being operational overhead. As the system which we had was not only fragmented, it was also self-hosted. Thus, we have to make sure that we manually provision the system, upgrades are in place, and at the same time, this is highly available and disaster recoverable. The second challenge being, as the tools were fragmented, there was no unified context, thus making it harder for developers to debug it manually. The third challenge being scalability. We have something called as Prometheus in our ecosystem for storing the metrics. As this is single node system, it is not horizontally scalable. Thus, we have to bring in another tool called Thanos in order to make sure that this is horizontally scalable. The fourth challenge being limited integration. As these tools are self-hosted with limited capabilities, for every another integration, we have to bring in another tool. For example, in order to have on-call scheduling and escalation in place, we got another tool called OpsGenie in order to ensure full incident management is in place. Now, let's look at what exactly the MIQ ecosystem looked like. So, as I mentioned, we have close to 20 nodes where our applications are deployed. On top of it, we had our observability layer. What this layer looked like? For logging, we had Mesmo in place, which is a which is a SaaS tool for storing and visualizing logs. Then we have Prometheus for storing our metrics, and then Grafana UI, self-hosted, for visualizing and setting alerts. In terms of tracing, we had OpenTelemetry for instrumenting the code and collecting the traces, and the Jaeger to query the trace and then provide a visualization layer. On top of all these three, we had a response layer in order to ensure that full incident management is in place, where we used to use a tool called OpsGenie. Now, how? Now, what was our roadmap from for the transition from this particular ecosystem to the newer one? First thing which we did was build versus buy. We defined the scopes clearly, we created a feature matrix and started looking for tools which are already there in open source ecosystem. We did a comparison, went back to leadership that we wanted to go for buy, as we could not find a tool which is open source at the same time satisfying our all our feature metrics. Then we did the vendor analysis. In vendor analysis, we conducted industry-wide vendor assessment. We did a quick connect with logz.io, dynatrace, and then Splunk, and in the last but not least, Grafana Cloud. We did the comparison, we compared the offering, we scheduled the demos, we evaluated features at the same time cost. Based on all of these, we finalized Grafana Cloud as our vendor where we wanted to do the POC with, and then logz.io. When we did the POC, we signed an NDA, we initiated a trial, and then started testing the features. And based on the performance, we also started planning the onboarding, how exactly we'll migrate our logs, metrics, and traces, at the same time keeping the previous one intact. We started gathering the user feedback and closed the POC that yes, we would want to go with Grafana Cloud, and closed on our migration plan as well. What this plan looked like, we'll be talking about it in the upcoming slides. Then we started involving our procurement and legal team, finalized the contract and financials, and started the migration planning. In this, we planned for all four logs, metrics, traces, and alerts. And once we are done with the planning, we started migrating our logs, onboarding Grafana UI, migrating the traces, and in the end, we started performing cleanup for metrics, as we had close to 400 billion active series metrics, which is huge. If we would have migrated the entire one, it would have costed us a lot. Thus, and at the same time, there were a lot of metrics there which were not even getting utilized, which were redundant. So we started following up with teams, and then after cleanup, we performed the Prometheus migration. Now, what was that cleanup? How we did the cleanup? What were the steps involved? Let's look at it in detail. Let's hear about that in detail from Amrish.
So, after exploring a lot of different tools like Grafana Cloud, Datadog, Splunk, Logsy, etc., we finally went ahead with Grafana Cloud because it gave us a lot of enhancements like correlation between logs, metrics, and traces, everything in a unified single view, etc. Because we were already on Grafana self-hosted, moving to Grafana Cloud would be very easy. Migration effort would be very less. Grafana also provides dashboards which help us in getting the drill down of our cost for metrics, logs, and traces. Now, coming on to the migration strategy, let's first see the assessment of our current infra, and the issues which we faced. The very first thing is fragmentation of tools. For logs, we had LogDNA stack. For metrics, we had Prometheus and Grafana stack. For traces, we had Hotel and Jaeger stack. So a lot of different tools to maintain. Now, because all these were in different platforms, there was no correlation between them, logs, metrics, and traces. So users had to jump between different tools for their troubleshooting. Uh, we saw some logs having tokens which were getting pushed. Uh, Now, if we were not able to pinpoint the exact application which spiked the ingestion of logs in LogDNA. Also, we also saw that around 80-85% of the metrics which is being stored in Prometheus is not being queried on through Grafana. So there were no dashboards that were built on 80 to 85% of the metrics. There is one very standard problem which people face with Prometheus is the filling up of disks, which can either be solved in two ways. Either we increase the size of the persistent disk, or we clean up the older metrics. We have around 8 Kubernetes clusters, and every cluster has its own Prometheus stack, which increased our maintenance overhead. Also, we had less retention of data. Like for logs, we had 15 days of retention. For metrics, we had 3 months to 6 months of retention in our uh, dev and production environments. For traces, we had 7 days of retention. We also used to get too many requests error uh, when multiple users are querying the Jaeger UI at the same time. Now, coming on to the optimization, the very first thing that we saw is we can reduce the amount of tools that we are using. For example, we have 3 different stack for logs, metrics, and traces. Let's overall move to a single tool called Grafana Alloy. This will remove all other tools. We also planned on analyzing the metrics and remove the unnecessary ones. For migration of the dashboards, alerts, data sources, everything from our self-hosted Grafana to Grafana Cloud, we planned on using a tool called Grizzly, which is an open source tool from Grafana itself, which does very seamless integration. After the metrics analysis was done, We got a list of metrics that we can remove and will not be retained in Prometheus. We planned on also making use of adaptive metrics feature of Grafana, which is a recommendation engine that tells us whether we can remove the metric or aggregate this kind of metric, or we can also remove a few labels from the metrics. For tempo, we planned on increasing the queue length so that we can store longer traces as well. Now, coming on to the operations part, we had our so PCP is a program in our internal MIQ where we take a few members or take representatives from every team and we train them on platform tools and the best practices of our platform. This leads us to faster adoption of our tools across teams and faster knowledge sharing as well. After installing the Grafana Alloy, we use the relabeling rules to drop the metrics, and we also use relabel rules to drop the logs as well. We are currently monitoring the cost and from the pre-built dashboards of Grafana, which gives us detailed insights on how each metric or log or trace is contributing in the overall cost. So firstly, we migrated logs, then traces, and then we also explored and implemented on-call feature in Grafana, which is an alternative to OpsGenie, which is a paging service. After configuring on-call in Grafana, we removed OpsGenie as well. And finally, we migrated metrics from self-hosted to Grafana Cloud. Now let's see the impact. The very first impact is we removed around 18 plus tools, and we only have one tool, which is Grafana Alloy to manage. Uh, this this led us to SREs uh, doing more explorations across other tools. The ease of use, which is Grafana itself provides a drill down of metrics, logs, and traces, where we don't need to write trace QL, prom QL query languages. We can simply use the UI to navigate to different traces, metrics, and logs. Cost wise, we saved around $10,000 per annum by eliminating our older infra and using only Grafana cloud stack. We also optimized alerts, removed the false positives, and excess noise. We got longer retention from Grafana Cloud, which is 1 year of metrics retention, 30 days of logs retention, and 30 days of traces retention, which is more than twice for logs and metrics, and near about twice or even more than twice for metrics as well. Now, because everything is in a single platform, the hopping between tools was gone, and the debug sessions became faster. We also have a dedicated support if we face any issues. After all this, when we now became stable in logs, metrics, and traces, so now it was time to explore other features of Grafana, like functional mount. So recently we released another product called MIQ Sigma, whose uh, load testing, performance testing, browser checks, and everything we did from functional monitoring itself. It gives us detailed dashboards on the data, on the load testing data, and it also gives us alerts on top of it. We also explored and implemented front-end observability, where it tells us where it gets the data of how much time the first component of your page took to load in, and how much time your whole page took to load in. And based on all these data, it creates visuals for us to analyze. Along with this, we also have scope of exploring other features like application observability, ingestion optimization, and auto instrumentation. Thank you.